All right, everybody. Hello. Welcome to AFCOM Southern California Chapter's third quarter 2025 educational series webinar, where we are in essence going to be talking about what we learned at the big YOTTA Data Center Conference in Las Vegas a few weeks ago. Before we get going into the full agenda, and we got a full hour here, I want to make sure we have an opportunity to introduce our board. And so for the board members that are on here today, why don't we kind of take it from the top? I see, Di, that you're on, and people up in LA, if you can introduce yourselves.
Okay,
I don't know if David.
my name is Diane Crayfield-Ellison. I've been a part of AFCOM, I think, for 4 to 5 years now. I'm the owner of DKKD Staffing, and I've been building teams across the U.S. for the last 25 years, from CIO, CTO, CISO down to help desk, HR. Of course, that includes data centers, and that's my interest in being a part of AFCOM as well. We're hoping that that market's going to come back quite a bit now. In my 25 years, I've seen a lot of changes, and one thing that's inevitable is we have to stay abreast of future technology and figure out how to adapt. Obviously, AI is a big part of our current and future planning. Our AFCOM panelists will speak more about what they're seeing on their end, and Jason will share what he learned at YOTTA. Of course, the AI sessions had the most attendees. This year has been kind of slow but steady in the staffing arena. We've personally been filling a lot of leadership roles, architect, developers, more quickly than we expected, but that's due more to so many candidates on the job market. And as an example, one of the VPIT roles that we recently filled had over 600 applicants in just a couple of weeks. So it's a lot to go through. And recently the job market has picked up and shifted a bit, and surprisingly in the need of desktop support. So there's a lot of issues going on where they need more desktop support and data analytics. So the companies are going in and scrubbing their data because there's duplicates and overloads. And what CIOs are preparing for in the coming year are, building new product and infrastructure teams, and to realize and how to adapt to the value of AI. So hopefully this will be a very positive outlook for the job market. And, roles such as chief AI officers are out there, and the teams that they're going to build, and hopefully we'll be building more and supporting the data centers as well. So back to you, Jason.
Okay, so let's introduce the rest of our board. So again, the rest of our members who are on from LA, why don't you introduce yourselves?
I'll go ahead. This is Yeet Bullet. I'm with Ramble. We are a global consulting engineering firm, and we provide pretty much cradle to grave services associated with all sorts of facilities. But in particular, I'm part of our data center facilities group, and we specialize in the planning, design, and commissioning of data centers and critical facilities. Located in Los Angeles, and I've been a part of the AFCOM board, probably about 4 or 5 years. I've been around in the industry for much, much longer than that.
Great. I don't know if you have anybody else on from LA, but let's go down to San Diego. Brad.
Hey everyone, thanks Jason. Brad Schulteis here, Director for LDP Associates, covering the Southern California market. And we are a manufacturer's rep for the APC brand of Schneider Electric and a couple other business units within Schneider Electric. Been in Southern California in the data center market since, I guess around 2000, maybe 99. So 26 years, and we're finally starting to see that that boom that we all barely touched back in 2000. So good times ahead.
Okay. I don't know if Doug, Caitlin, or Thomas want to introduce themselves.
How's it going? My name is Tom. I'm the data center manager for the San Diego Supercomputer Center. I manage the facility itself, a hyperscale facility, an operations team, and a networking team. Been with AFCOM for about 3 years, in the industry for about 15. And some of the things that we're currently seeing is additional liquid cooling installation is required. Additional power, far beyond what the scope was previously. So yeah, things have been changing quite. quite frequently, and I'll get into that a little bit later.
Great. Thanks, Thomas. So I don't know if we got Caitlin or Doug on as well, but what I'll do is I'll introduce myself real quick. So I'm Jason Shepard. I'm the president of our chapter. I've been on the board since 2014 and been in the data center industry for 30 years now. I've kind of dated myself, but in my day job, I'm a site selection scout for data center facilities. I founded the ICE site selection practice. I've done a number of the big data center projects here in Southern California, and I'm really honored to be part of our team. And I'm also very honored to be able to work with our board members because we are a not-for-profit organization focused on education for the IT operations and data center operations community of Southern California. We're lucky enough to have on the president of our Arizona chapter. Ryan, would you like to introduce yourself?
Absolutely. Thank you, Jason. So Ryan Groover, I am the president of the Arizona chapter. Restarted which was the Phoenix chapter about eight years ago. So 2018, we got this chapter restarted. Growing the board now, we're actually the 8 members, actually looking for a 9th right now to be a director of education for Tucson. If you've been around data center world, you've probably seen one of my presentations. I've presented there since actually 2020. And you may also know me from the infamous rack and stack competition. So where I put data center professionals head to head and in the ultimate game of rack and stack. Day job, I run 7 data centers and 1,000 edge sites for a very large healthcare organization here in the Southwest.
Thank you very much. So, you'll notice at the bottom how I've broken out our board members between regions, and so we currently have our called 4 members up in LA. We got our 4 members in San Diego, and I'm currently the only one at Goldilocks Porridge here in the middle in Orange County. So we are looking for additional board members in Orange County. So if you are interested, please reach out to me and we can coordinate times with the board to discuss. We are, again, a not-for-profit organization, and so this is a non-salesy environment. It's all based upon education. And so what we want to share with you all today is going through the big data center conference at YOTTA from 2 weeks ago there in Las Vegas. And I'd like to kind of make sure I have Ryan's perspective and Thomas's perspectives as the end users. And let me kind of talk about what I mean there. So for those who haven't seen one of our presentations before, I like to level set at the beginning of who our community is. Okay, so our community here in Southern California, the 2nd largest metropolitan area in the country, there's not a single hyperscaler headquartered in our marketplace, right? So we have this tendency to go to the data center worlds. We go to the YOTTAs, we go to the data center dynamics conferences of this world, and we see all these great new technologies that are being utilized by these mega scale data center facilities that sometimes we kind of go, well, how does it really apply to us, right? Corporate America, the IT operations teams for those brick and mortar companies, right? So that's why I want to make sure I've got both Ryan's and Thomas's perspectives as the end users on our panel discussion today to really kind of talk about, hey, what applies, what really doesn't apply. But I also have the brilliance of guys like Yeet and Brad on the panel today who could talk about it from an engineering standpoint, what that means. And also having Di on the panel from a standpoint of IT recruiting and what does that mean? Okay, so a couple things. Before I said enterprise, I always looked at fundamentally there were 3 types of data centers. Corporate America, we call this enterprise data centers. The hyperscale companies, these internet-centric search engines, right? So the 500,000 square foot, million square foot type data center facilities. And then we have the third-party operators, multi-tenant data centers. We call this co-location, right? Not everybody's just going to go build out their own full-scale tier 4 data center facility for a few racks, right? They go lease space inside of a multi-tenant co-location facility. We call that 3PO model. Well, in the last 2 years, we've seen this insurgence of this new type of data center customer, AI, right? Artificial intelligence, where your traditional corporate user might have 3 to 5 kilowatts of power in a rack. The hyperscalers maybe start at 25 kilowatts of power per rack. Well, the 3PO model really caters to both, so maybe call that 15 kW per rack type of a model. We're seeing these AI requirements coming in starting at about 40 kilowatts of power per rack, really 60 kilowatts of power per rack. And we'll even see in some of the information we're going to share today, that's going even higher and higher and higher. But Not all data centers are designed the same. And the facility you might have for one data center customer or user is going to be completely different than you can use for an enterprise customer, if that makes sense. So let's talk about where we were. Let's level set again here for a second. Back in May, at Data Center World in Washington, D.C., AFCOM, the parent company that we're a part of, they put out their annual data center state of the data center report, where they noted we're at number one, we're at all-time low vacancies in co-location facilities, right? Very low inventory right now for corporate America to go out and just go acquire their 10, 20, 30 cabinets inside of a co-location facility. Rack density is increasing. Now, just because you see in this top bullet point here, 2021, 7 kW per rack, 2025, 16 kilowatts power per rack. That doesn't mean that's what everybody is doing. This is just what the facilities are being designed to now, okay? Now, 79% of the actual survey respondents expect that rack density to increase with AI. 65% expect further increases over the next 2 to 3 years. And right now, you'll see that one of the biggest challenges that we're facing in the industry today, and Yeet and I were on a call earlier today with another client, where the energy supply from the actual utility providers is becoming hard to come by. So what we're seeing right now is 62%. Again, this is from the 2025 State of the Data Center Survey report. 62% of respondents are looking to bring on-site cogeneration on-site to supplement what they're getting from their utility provider. Cloud repatriation. This does not mean that people are moving away from cloud in full, but 80% of survey respondents say they've been moving some of their applications, some of their load back to their own corporate data centers, whether that's an on-site co-location facility, an on-site data center, or at a co-location facility. But we also know that data center vacancy rates are at all-time lows. So right now we're in this pickle of people trying to right size, going back in part from cloud, but having no place to go, right? So it's a big challenge in the marketplace today. So 80% believe AI workloads are going to drive power capacity requirements in the marketplace, which leads us into the next session that we're going to talk about here, which is what did we learn at YOTTA? Oh, but before I go there, I did want to kind of share this article that came out in the Harvard Business Review from July. And this is where the discussions of the new administration, federal administration, is rolling back the SEC guidelines for climate disclosures, right? So how does this impact us? Well, what you've seen is a lot of these publicly traded companies who have their check boxes for their climate considerations have had in prior administration have had to kind of make sure they're really sticking to those check boxes. Well, now those requirements have been eased under the new administration. But even at YOTTA, we've seen that this really isn't changing a lot of the mindset, a lot of the different IT teams, how they're deploying their go-forward strategies on green energy and climate considerations. So one additional thing you'll notice from me, and what we did was we took out, in order to save time, we took out, I had taken a copy of all of the different sessions from YOTTA, and I color coded those based upon what people are talking about. Red for power, green considerations, green, surprise. Cooling was blue, and AI and these and purple. Okay, so if you want to see that information, you can check out our LinkedIn page, where we'll share more of those slides. And again, for everybody's reference, we are going to be uploading this session like usual to our YouTube channel, so our viewers can view this at will. So the first session that I was an attendant, and by the way, I've got to thank Ryan, because prior to going to this event, Ryan made a great recommendation for me to download the app for the iPhone, Fireflies, which is a great AI app, which you literally walk in, you push record, it records literally the entire transcription, but it also provides you summaries. And it's fantastic. Everything that you're looking at here is the actual summary that I can actually cross-reference with the actual hard copies that I've actually printed out here in my hand, which is not very green, by the way. I don't recommend printing out a small tree. But the first session that we want to talk about was the pathway to power. And this particular session, we had the guy on the screen, the lower left-hand corner, the far right. He's the economic development guy, Buddy Reiser from Loudoun County, Virginia, arguably the top data center hub of the country. And what they're seeing is unprecedented infrastructure growth in their marketplace and demand for power. 100 gigawatts of AI projects they're tracking in their marketplace. But the thing you also got to remember is that there are 29 states across the United States that have renewable energy laws. Okay. Well, in the state of Virginia, that renewable energy law is 100% renewable by 2045. Here in California, our renewable energy law is 60% renewable by 2030, which is impacting power rates, et cetera, to the point where Buddy referenced there that, hey, these are unrealistic targets, and there's so much power demand. What is driving users to do, particularly on the AI side, that are not publicly traded companies that may or may not have those restrictions for green energy, to look at on-site cogeneration to supplement what they're getting from their utility provider. And I'll pause here for a second to see if there is anybody from our panel who would like to make any comments for what we're looking at here on the screen.
And yeah, Jason, I can speak to that. We're currently seeing the same issue here at my facility. It is all about power at this point. That's the major constraint that we're seeing. We went from an average of about 5 kW to rack to about 15 to 20. With the most recent racks that we brought in being 90 kW, 150 kW, and then the pipeline is 200 kW racks. And we're scaled and set up to potentially accommodate up to 600 kW racks. And that's what we're setting for.
Wow. Let's pause for a second. 600 kW racks. How do you cool these?
So it's going to be a combo of DLC and rear door heat exchangers. Some of the highest density of both of those combined is the only way that you can actually cool that much. So you need 25% of air cooling for any DLC solution. So you have to have 150 to 200 kW rear door heat exchangers in order to accommodate. And another trend that we're seeing with the power delivery is going from 208 volt to 480 volt power. All the newer racks that we're bringing in, they're taking in 480 directly, doing a conversion to DC in the rack, and then feeding the rack servers themselves from DC power. It's a more efficient way to deliver. You skip having to transform down from 480 to 208 volt. So infrastructure-wise, it makes sense to be a quicker install, and it's more efficient using DC power as opposed to AC because there's less loss. And then also in the pipeline for us, we're even exploring direct DC power, which is going to be potentially 600 or 800 volt directly fed to the servers, to the racks themselves. So yeah, there's a huge migration in power, and we don't have any current power strategy that is set in stone. The past 30 years, it's been 120 volt, 208 volt power. That's the standard delivery to racks. But now, things are changing and we're pivoting to 415 volt, to direct DC, to 480. So power strategies are, evolving. And so, yeah, it's an interesting landscape.
And being that you're affiliated with obviously the university system, right? Now you're not just for the universities in San Diego. You're actually providing data center services throughout the universities throughout California, correct?
Correct. Yeah, throughout the entire state. We do have external customers. We have healthcare customers. We have a significant amount of overall infrastructure. Not one set client. The majority is probably UC San Diego, but we do have a significant amount of UC infrastructure as well as external healthcare companies.
Let's talk about reliability and redundancy for a second, because the universities almost describe them like the Dr. Jekyll, Mr. Hyde requirements, right? Where you have the engineering team coming in and saying, hey, we need lots and lots of capacity, but we really don't care that much about the reliability. Then you have the medical school side saying that we don't need as much reliability. I mean, we don't need as much power capacity, but lots of reliability, right?
Mhm.
How are you set up to kind of service that two side?
So our service offering isn't uniform per rack with power delivery. It is take it or leave it essentially. So we can deliver street power, we can deliver UPS only power, or UPS and generator back power. So it's essentially what the customer requires for their workload. We have some customers that they have large supercomputers with 10 to 20 racks that are all on street power, except for the management nodes, which are on generator backup. And if the street power does go down, they'll lose jobs, but the management nodes will know where they left off or pick them right back up from the start. So there's not necessarily a loss of data overall as the management stays up.
Ryan, do you have any comments
Yeah,
on your
well, I was
end?
gonna say what I observed, here in the Phoenix region is, we're while we're not number one, we're not Landon County, we are, maybe arguably like a number two in the nation here in the Phoenix metro, and it's the local utility companies are struggling with all the data center builds. We got, the west side of Phoenix, it's mega campuses coming up. Where I am in the East Valley, again, mega campuses coming online right now. SRP, APS are having problems getting really that delivery. I'll say today I'm in sunny Tucson, and that's where we're probably going to start seeing the emergence of a secondary market down here because I think TEP has a little bit more power available. But yeah, I know my peers in the operator space are definitely a bit worried about the power delivery with just the sheer amount of data centers going up in Phoenix right now. So it's interesting times.
One of the things is going back to that, what we saw there at YOTTA and the notes down the second from the bottom of the power infrastructure. What we're actually seeing here is particularly on the AI side, you're having these voluntary demand response programs. And this is an instance where they can require that you go offline, right? And go off on your own power. A lot of the corporate users, the traditional enterprise users, would have probably been very, very concerned with that in the past. But a lot of these AI requirements are being forced into these types of circumstances. But they're also looking at situations where there's becoming this grid partnership with these facilities doing on-site cogeneration, where they can actually sell some of their power back, their generation back to the grid, if that makes sense. And the other thing I'll show down below is they're talking about a lot of it's almost kind of like one person's excess is another person's benefit, right? You have a lot of these older retired coal power plants, for instance, that house all this infrastructure they don't know what to do with. Well, looking at converting a number of these old sites to data centers or for on-site for new power plants and so forth. So, and yes, it's the time I'm going to move on to the next slide. The next slide we had was the gigawatt. It was called Blocks to Blackwells, right? This is where we had Daniel Roberts, the CEO, a co-founder of IREN, who was a Bitcoin operations group. And that Bitcoin operations group is basically converting a lot of their Bitcoin mining operations to mega hyperscale AI factories, right? Which is just interesting. And you're talking about huge power densities, 2 gigawatt campuses, 1 gigawatt, a gigawatt, that's 1,000 megawatts. I'll just put that in reference. Some of the deals that we've worked on in the Silicon Valley, right? And those colo facilities are 9 megawatts, right? We're talking about gigawatt, 1,000 megawatts. These sites are all substantial amounts of power, but it's just kind of showing where the industry is heading. But the one thing, and maybe Yeet, I'll ask your thoughts. What is the difference between an AI design facility and a corporate enterprise data? I mean, are they the same level of reliability and redundancy?
Yeah, so I mean, let's talk about a couple of these things all at the same time here. The first thing is this migration from bit mining to AI factories is very real, and there's a lot of companies that are doing that right now because a few years back before AI really took off, the hottest thing at that point was bit mining, right? And it was essentially this a lot of investment was going into people buying large tracts of land and getting into power agreements with the local utility companies, and not necessarily the primary markets, not necessarily the Loudoun counties, right? But in the secondary markets, et cetera, which was suitable for them in terms of Bitcoin mining. Well, with the AI starting up, we're seeing across the country, across the world, barely, that a lot of the utility companies are either capacity or delivery constrained in being able to service these large campus of data centers. Well, all of a sudden you look at this and you go, well, wait a minute, I've got the land and I've already got the power agreements. Uh, the difference is, of course, is a Bitcoin mining data center is a lot different than an AI data center and is certainly different than a corporate data center. If we look at these in terms of what, how they sort of stack up, let's talk about the Bitcoin miners. Bitcoin miners, they don't really have a very high reliability concern. Their particular objective is a lot of power, raw power, no backup power. Typically, they don't have generators, UPS, hardly ever actual active cooling. They are looking for just servers that are grinding away and essentially, making them money, right? Reliability is not particularly high on their list of requirements. Now you go on to the opposite end, an enterprise data center. Those are typically your clients. Those are your sort of customers that are not typically as power hungry, but they are concerned about consistency and reliability. Those are the facilities that are going to have the high availability requirements, 5 nines of availability, probability of failure very, very low. Now the AI workload is somewhere in between, kind of like what Tom's talking about earlier, right? Is that, you know, when you get to those very, very high densities, one, it becomes harder to essentially maintain those levels of redundancy and do it economically. But also, you have to be a little bit more practical about this. One prime example of this, from days of old that are sort of come back is, if you ever deal with, and I'm in Los Angeles, so we do work for studios, digital rendering, right? A lot of these customers, the Apple, others, Pixar Pictures, they have, data centers where they do high performance computing for their rendering, for their animation, those sorts of workloads. Now, a lot of times those workloads are not UPS backed. They're basically on either street power or generator backed. But what's important is the core content, and that's on their storage and their management nodes. Those are on 2N UPS. Those have to be reliable because you can lose a batch of rendering, but then you can start that process over, if you will. So in terms of your question there, Jason, bit miners, no reliability, a lot of raw power. Enterprise users, more reliability, not quite as power hungry. And the AI is somewhere in between those two extremes.
So I guess where I'm trying to get to this is that for a lot of our constituents here in Southern California, they're competing against these AI requirements and hyperscale requirements for colo space and capacity. But it's not like we're comparing apples to apples. A 2 MW Caterpillar generator is a 2 MW Caterpillar generator, whether it's at a colo facility or at an AI factory. But the design is not quite really the same. You're not going to operate a enterprise user out of a hyperscale facility.
Yeah, that's not likely. And the challenge too, what you were talking about these vacancy rates now is, part of what's also going on is a lot of these colo providers are actually as well catering to the hyperscalers. So the demand is so intense right now, and it was intense even before the AI boom, for the hyperscalers to essentially scale. They can't build data centers for their own use fast enough. So they've been actually gobbling up whatever data center space they can get, whether it's built to suit co-location or existing co-location village. So if you're an enterprise user and you're trying to find a co-location provider, it's kind of like, it's kind of hard for them to give you a deal. They might not even talk to you at this point.
Mm-hmm. Yeah, and I would say, vacancy rates are at all-time lows. I think that may be later in this this chat here, but even, personally from an end user point, we have denied many requests for racks in the last year or two, just because space vacancy is so tight. And it's, because of this demand, it's just increasing it exponentially.
And if you find an empty rack, you better claim it right now.
So the next slide here. So let me just kind of explain how YOTTA was set up. So it was a 3-day conference. The first day they had the Infrastructure Masons Climate Accord, and so they had their breakout sessions in the morning on the climate accord versus cooling infrastructure. The second half of the day one, was set up as almost like a Shark Tank, right? So you had a number of different companies presenting their ideas to the larger audience. The second day at YOTTA was literally 36 different sessions, all different breakout sessions. It was kind of crazy. I could only go to so many. And then the last day was very similar to day two. But one of the breakout sessions was under compute recalibration, right? Redesigning the actual facility. What's going on today, right? So the chair of that hall, Sean Varley, did a great breakout introduction. This is a very, quick 15 to 20-minute session. But he had a lot of great notes here. And he was talking about the growth of AI requirements. The growth is they're looking at 35 compounded annual growth through 2030 for this industry, which is already on fire. Now, let's just keep in mind that the industry, the power companies today, and maybe Todd Sword, I see you're on from Southern California Edison, and maybe you guys don't have energy supplies, but many states across the country, which are primary data center markets, the utility providers are back on their heels. And they're literally saying, hey, we can't get you that kind of energy supply for X period of time, right? Maybe it's 5 years, maybe it's 7 years, right? Again, that's the real issue right now is the energy supply. So with 35% compounded growth annually from now, this is kind of a challenge. And in fact, you look at the last bullet point under the top section, they're kind of describing right now as the AI gold rush, this period that we're in, the AI gold rush. Powered on-site power consumption today they're looking at it as a new paradigm shift, and just the growth of it is just insane. So I don't know if anybody on the board wants to tackle any of this.
Yeah, I mean, I think like we touched on it a little bit earlier, right? So most of the utilities are either capacity constrained or they are delivery constrained, right? So they have the generator capacity, but they don't have the transmission lines or the distribution lines to get that that capacity to the site, right? So the challenge has been is that the power industry, we have for decades. I started my early career out in the in regulated power industry. At that point, we were talking about the fact that we were not upgrading our facilities, and that was nearly 40 years ago. And that's been the ongoing story. As time has gone on, we've given up on contingencies. We've started running our systems harder, and we've lost generation capacity, whether for aging plants, whether they were coal powered, whatever that was. All these are all constraints that are making almost all the utilities across the country somewhat, in a pickle, if you will. And I think Edison, Southern California Edison, historically, one, there were not a whole lot of large-scale data centers wanted to go into Southern California for various reasons. They still have capacity, as I understand it, and they've been one of the more responsive utility companies in terms of being able to tell you where you can get the power and how long, and how quickly you can get it.
Yeah, maybe I'll jump in real quick. So yeah, you're exactly right. We don't have any really super large data centers yet, but they want to come now. And these are AI data centers that are all looking for 50 megawatts and plus. And we do have the capacity up to a point, right? When I look at our A-bank circuits across our territory, this is the 220V to 66, they all have between 150 to maybe 250 megawatts available, right? So that's where we do have infrastructure ready to go. But any one of these large data center companies that come in, they could gobble that up in a hurry, right? And now everybody's going to have to wait, But in general, I haven't heard any issues on our side with getting generation capacity. We seem to be doing fine with that, and we're creeping up on the renewables. We're almost at 50% now, so we're supposed to be on track for 80%. But data centers could throw those numbers off pretty hard if we start doing it. What I am excited about is our president is actually ready to switch to try to go more aggressively towards attracting data centers and moving away from transportation electrification now that we kind of have those programs dialed in. So we are starting a team that's identifying good power sites, and we're going to be marketing those. And to an earlier thing that Thomas mentioned, we actually won a $50 million grant from the Department of Energy to do a DC substation that we're looking for data center partners to actually line up with and maybe do kind of a campus where we could provide a lot of DC power. And that again provides extra capacity, lower costs, and less line losses. So a lot of good opportunities there.
In the essence of time, I'm going to keep moving since we've got about 25 minutes left in our scheduled time. But want to make sure we leave time for Q&A. And Brad from our board is going to be kind of watching the chat section for the end. Again, just type into the chat section what your questions are for Q&A, and Brad will look at those. A couple of other things. So they had a great session where Rebecca Weekly from Geico Insurance was on stage along with the chief technology officer from Digital Realty Trust, again, the 800-pound gorilla. And they were talking about, again, just different challenges. And I know, Ryan, I think that you had mentioned kind of an issue here, no, a comment here, but there's the MIT study that was finding that the AI hype and the narrative out there has been failing miserably for actually corporate users, right?
Yeah. I
You want
think
to
trying to
comment on
roll
that?
your own is just it's just too I don't think most enterprises are capable of actually doing the roll their own AI. I think that you'd want to bring in, someone who's actually skilled at it, versus trying to just again, you're wasting money. Go buy something off the shelf. That's probably the best way I can put it.
Yeah. Yeah, I guess the overall I guess the comment is that in the world of, and again, I don't know if anybody wants to kind of comment on this, so I kind of give the generic version of it, but in the world of AI, there's the testing section of AI, right? And then we're talking about facilities that can get, in essence, go 400 to 1,000 kilowatts per rack,
Mhm.
right? An entire megawatt in one rack, right? And these things are all kind of get your foot on the gas pedal. You're running that energy, doing that search. But once you've mined your data, then it becomes more of a stabilized type of a load, right? So again, that's why I almost described it a little bit more like like these AI requirements are more similar to the universities, right? Where you have these huge engineering requirements and these huge loads during the testing, which then shift into a more stabilized load, still high, but still stabilized. Um, so, but anyway, so again, just trying to move on the essence of time here. And by the way, we're going to share all these slides to our LinkedIn page if anybody wants to see it. And then also this recording is going to be uploaded to our YouTube channel. The next one we had, and a fascinating session where you've got Chris Dolan from Crusoe, you got the chief strategy officer from CyrusOne. They're all talking about the really unprecedented growth of power, and they were talking about 9 to 136 kilowatts of power per rack, but we all know that's actually kind of low, right? But they were talking about the supply chain imbalance that, right, this is where Thomas, you were referring to right now, the vacancy rates, they actually put a number to it, 2%, 2% vacancy. Well, when it gets to 2% vacancy, people start getting um, uh, priced out of their own co-location space for renewals, right? And then they're trying to scramble what to do. Maybe enforcing them into public cloud, which is also can be very expensive. Public cloud is not going to break it all down, but you got the software as a service, infrastructure as a service, platform as a service, blank, blank, blank as a service, right? All the different types of clouds. And by the way, another pet peeve, it's not the cloud, just say cloud, because it's really multi-cloud, right? But that said, we are really seeing a revolutionary impact on the timeline for power and scale. We're talking about multi-gigawatt campuses. But I also kind of found interesting down a second from the bottom, inference workload latency, right? Just so we're all on the same page, latency is the time it takes for two data centers to sync from a telecom standpoint, right? If you go past that, let's call it that 25 fiber optic route miles, right? You get that lag time. That lag time between LA and Phoenix and back might be 11 milliseconds. LA and Salt Lake City and back is about 18. LA to Denver and back is 27. Why does that make sense? Well, according to the 2023 data center survey from AFCOM, over 60% of survey respondents said they had to be at or below 20 milliseconds, right? So now we're in a situation where, okay, well, where are these AI data centers that may have their latency restrictions back and forth to whether it's a customer or what have you? These make sense. They just can't go out in the middle of nowhere, right? They still need to have access to talent. They still need to have access to redundant fiber optics, right? So again, we are starting to see that inference workload does have a latency restriction. And again, just another comment of behind the metered strategies are really taking hold. Again, behind the meter means on-site cogeneration. And by the way, there is a great book called The Grid I'm reading that talks about how the original power in the United States during the Industrial Revolution, everybody had their own on-site power plant, right? And it wasn't until later that the power grids came along. Well, now we're starting to see a shift back towards on-site cogeneration to supplement what you're getting from your grid because of those limitations. Okay, next slide. This was probably the most well-attended session that I was at. I don't have as many notes from the actual session here, but you had OpenAI up on stage talking about their new grids, excuse me, their new sites and their gigawatt plus clusters of data centers that they're building. For example, they're in partnership with Elon Musk, right? What they're doing in Texas. But again, a lot of concerns around power there. We do have, and probably this is someone, Nate Franklin, who Pacifico Energy, and Nate's actually located here in Orange County. I'd love to have him on one of our webinars coming up. But he was also talking about what they're doing from an on-site, helping customers with generation, and talking about the dysfunction of the interconnection process. Remember what, so most of these big conferences, I know there was a lot of discussion at Data Center World about people talking about they've got powered land. Like, what do you mean powered land? What is your cost per megawatt of powered land? I'm like, okay, well, last time I checked that the power company owns that power capacity, not the property owner, right? And so unless you have your own substation on site, you don't own that power. Southern California Edison owns that power capacity, right, Todd? So for me, it's finding the sites that have the power capacity, or have the on-site cogeneration capability to supplement what your utility is going to provide you. But anyway, you cut it behind the grid, power is really coming to the forefront. Don't have a lot to talk about on this particular slide, but again, just another illustration. Have one session after the next, the big kingpins up on stage talking about new on-site behind the meter cogeneration, and this was from Bloom, which is what we're talking about, clean energy fuel cells. Now, there's a lot of debate whether or not fuel cells are considered to be renewable or simply green. They still do rely on natural gas, and I don't know if there's other fuel cells that use anything but natural gas. Any comment there? You're on mute. You're on mute.
Yeah, so for
There you go.
whatever reason, I was not able to get off mute. Anyways, yeah, so the primary fuel is typically natural gas, but you can get fuel cells that run off of biogas, such as off of a landfill. You can also get them that run off of hydrogen if you have a source of hydrogen. Generally speaking, the most common and the most readily available, first source is natural gas most times. They're not renewable because they are still based on a carbon-based, essentially primary fuel, right? And but on the other hand, from an emissions point of view and other sort of considerations, there's somewhat advantageous, obviously, to any kind of reciprocating natural gas engine and or turbines. And a lot of this conversation goes back to what we were talking about earlier, right? As these utilities, either by delivery or capacity constraints, can't deliver power to a site, all of a sudden, or do it in a timely fashion, what's happening is a lot of these mega campuses are starting to look at, well, we might just need to generate power on site, do our own power, generate our own power. Now, whether that's completely off grid or at least with some interaction with the grid, that's not without its own challenges. But, it's one of those situations where speed to market is your competitive edge, and you have a campus available and but you can't get the power there. You're sort of stuck, right? And that's why a lot of our clients and a lot of potential developers are starting to look at this as an option. But that's a paradigm shift. I mean, most data centers are run very well in terms of their MEP plant, but running a power plant is a whole different mindset and it's a whole different skill set. So that's a bit of an adjustment. But yeah, this is where all the conversation about small modular reactors for nuclear is coming about. Turbines are back on the scene again. Fuel cells for certain. All these are in response to this, the constraints that everybody's facing in terms of being able to get the power when they need it, where they need it.
Okay.
Yeah.
Um,
From
the,
the
Go ahead,
another end
Thomas.
user perspective, I was just going to say, we are currently looking into, whether or not we can deploy SMRs here. We have a coastal commission and, a campus beautification commission that we have to go through, which makes things extremely difficult. But we're exploring every avenue, the biogas bloom cells. We're even exploring putting a substation here directly next to us on campus. And
But by the way, let's just make sure, because I know both Yeet and yourself mentioned SMRs. That's a acronym for Small Modular Nuclear Reactor.
Yeah, and there's not a whole lot of appetite for that on campus currently. But personally, I think that's one of the next phases that we need to move into in this industry. The next 5 to 10 years, I think it will pick up.
There was a lot of chatter about SMRs. Google did an entire breakout session on SMRs and how they're really utilizing it for their platform. But again, I'm a huge fan of nuclear. So again, I think that it really is kind of a way of the future as far helping us. Well, nuclear is not renewable; it is green. It's low carbon emitting, right? So it's going to help with a lot of those goals. The last session I want to talk about before we, I think, take some questions if there are any, and if not, we can go back to overall board discussion. There was a session on beyond redundancy, and this was the first session that I saw. Well, I sat through. Let me just at least say that at YOTTA, where you really had, the Chief Technology Officer of the Uptime Institute. You had Bill Engel on stage. You had your team there, Yeet from Ramble. They're really talking about thinking beyond redundancy, right? So this is more geared towards the corporate user, right? In today's environment, in traditional designs. And again, I know we talked a little bit about this already, Yeet. But anyway, I'll leave this if anybody from the panel here wants to comment on anything we're looking at here.
Yeah, I'll say, at least what I've been seeing is, traditionally in the enterprise estimate, yes, we built like massive redundancies, your 2N UPS units, 2N cooling, all that. So then you didn't have to worry so much about the ITE going down at any point. It always stayed online no matter what maintenance or whatever happened. But, kind of putting on my DC hat, we're starting to see data centers built in kind of interesting places where, in one of the chapters on site selection, there's a giant list of things you don't put a data center near, like highways and fuel cells and nuclear and all that. But, well, where's the hyperscalers building? Near highways and fuel cells and pipelines and all that fun stuff. So, and they're putting in also, from what I'm hearing, a lot of more minimal redundancy. So it seems like my perception of it is they're now wanting you to buy like those extra services. Hey, go into a different region, go into this region, DR, buy a lot of nickel and diming is my feeling on it. Is that's what they want you to do is instead of like how we would do it in the past where everything was on-prem, that cloud stuff, yeah, they're gonna get you on it if you want that DR and that extra redundancy. So my opinion.
Thomas, any thoughts on your end from a corporate standpoint?
Yeah, I kind of got to echo his statement, really. I think at this point, it is kind of a pendulum shift. We're gonna, be moving away from that enterprise level power. It's going to be more, street power overall. That's going to be needed for these loads. And to Ryan's point, in order to get any level of redundancy, you're going to need multiple locations as opposed to being able to do it, DR locally. And so the colos themselves are going to be able to, make an extra buck, and it will be easier to nickel and dime because of the requirements of latency and the requirements of, local facilities. So yeah, I think it's a pendulum shift that's taking place really.
So the last I took two additional bullet points from other slides that I'd deleted just for the sake of time. But there was the bare metal documentary by Brandon Grease, and if you want to look this up on YouTube, it's a great 10-minute documentary. It was fantastic. They're just talking about 135 billion connected devices in this world by 2030. It's just dramatically increasing the amount of infrastructure that we're going to need to serve that. And then you had Oracle's chief technical architect was on stage in one of the breakout sessions, and they're talking about what's Oracle looking to do. Okay, well, Oracle is not one of these AI factories, but they themselves are looking for gigawatt campuses as the ideal size campus. This is huge. It's huge in the way of power and demand that's coming down the actual pipeline. It's just going to be interesting to see how we keep up with it. So what I'm going to do is I know we've got 10 minutes left, and if we don't have any questions, well, first of all, let me this. I do want to say one thing. So again, we are a not-for-profit organization. So we rely on our partners and our colleagues in the industry to help us stay afloat. And so we're going to be going back to doing in-person meetings for our chapter. During COVID, we shifted to everything online and it kind of just stayed that way, right? But we're going to go back to doing our in-person sessions. And you'll notice at the beginning, I have the 4 board members up in LA. I've got 4 now down in San Diego. But the whole idea is we're going back to a situation with our chapter. We're going to do one event, one of our quarterly events in person in San Diego. I think Thomas, you think you've already volunteered the San Diego Supercomputing Center for one of those locations, I believe. I don't want to put your feet to the fire. And I know that Todd, you've talked about maybe doing that one for us at Southern California Edison, right?
Yep. Happy to do that at Alhambra if I can find all the right players. But yeah, that'd be great.
Perfect. So the whole idea is with our board, we have 4 members in LA, 4 in San Diego. We're trying to add some more board members here in Orange County. But the whole idea is we're going to do one quarterly session down in San Diego, one quarterly in LA, one in Orange County, and then we're going to do our holiday social. But the rest of the time, those 4 members, we're going to do quarterly kind of impromptu or informal get-togethers, right? For, hey, we're all going to meet at this particular event for coffee or this particular place for some cocktails or what have you. So to really kind of help reestablish our community in person. But we do need our constituents. We do need our partners to assist us with that. So if you're interested in supporting our chapter, please reach out to us. We are going to be doing a holiday social. We have a committee on our team and our board. It's focused on that right now, to picking the date and again, getting sponsors for that. It's going to be a little bit different from how we're used to. We used to have a premier sponsor and then different levels of sponsors that kind of went down. Well, we're going to take the lead of our, I think it was our Northern Virginia chapter, where they're having smaller amounts, smaller stabilized amounts of sponsorships, but just more of them. And so if you're interested in being a sponsor for our holiday social, again, please reach out to us and we'll go from there. So let me ask you this. So Brad, did you see any questions come in? I know we've got about 7 minutes.
Yeah, one of them's been answered. Want to make sure that the PowerPoints or the slides will be available afterwards.
Yep.
Already answered that. A question from Barry Buck asking, talk about the difference between AI workloads, training workloads, and inference workloads. I don't know if somebody wants to jump in on this one. This one's a little hard to visualize. The one thing I've tried to use as an analogy is going to college, saying, working really, really hard to learn a lot of information, and then getting your job and actually using that information in real life. From what I understand, from what I'm told, the training model workloads require a lot of power, a lot of dynamic power, typically not high availability or redundancy, a lot of parallel GPUs, a lot of expense. And the training workloads the inference workloads are much lighter. Typically, we'll want to have more redundancy, and usually don't have to use the same type of GPUs. They might even run on a CPU. I would love to see if anybody's got anything to add to that, or if I kind of analyzed it.
Well, yeah, Thomas and Ryan, are you guys utilizing AI within your? I'm not talking about just high performance computing, right? I'm talking about what type of AI are your institutions utilizing?
So, I mean, I have a couple supercomputers that are dedicated to AI and ML. And essentially, most of them right now are just doing inference work. So it is kind of more of a steady load it's kind of run of the mill, mid-grade. You know, it doesn't fully peak out all these servers. The loads that we have had running, full training workloads, they go 100% or 0%. There's not really any middle ground. So there is, some issue with the grid feeding it. It's hard for some of the grid to actually feed, when we're going 100% down to 0%. Right now, we're working with the DOE on a potential grant to tie a UPS inline to one of our AI loads in order to measure that metric and potentially drop some of the load automatically via software as needed when demand events take place. And so that's, something in the future that probably a majority of the training workloads are going to be required to have is some sort of manual utility demand response. And that's kind of with that
If you
grant.
could, Thomas, and I don't, Thomas or Ryan or whoever wants to answer this, but it took some time when we started even dealing with the hyperscalers and the cloud models, right? Understanding what an instance was, right? And then like, oh, okay, that's the percentage of time you're utilizing an infrastructure services provider's servers, right? Is that the same thing really as an inference, right? Is utilizing AI? I mean, how would you define inference?
So, I mean, inference is the utilization of the trained models.
Yep.
And the training itself is you're slamming these models with all the data. You're just trying to fill it. And it's essentially, you're blasting scraped data into a database. The inference side is once it's all completed, you're actually utilizing that trained data to run models. And so you're not going to ramp as high and you're not going to have the same up and downs. It's going to be, a steadier workload.
Okay.
Yep, exactly.
And that kind of parallels the analogy I had with going to school, getting an education, and then using that education in real life.
You mean it's like cramming for exams and drinking a lot of coffee and energy drinks compared to like then sleeping in on a Sunday?
Yeah, not that our day jobs are any whole lot easier, but college was not easy as well.
Hey, Brad, while we got, has there been any while we're talking about demand, has there been any lightning up of lead times? Because I know like last year we had you talked a little bit. I don't know if it was earlier this year or last year. You were talking about lead times for infrastructure. How are lead times looking right now?
So I would say lead times have gotten a lot better, but they are still very long, and it really depends on what you're looking for. High voltage medium transformers still super long lead times. On the UPS side and a lot of the gear side, it's gotten a lot better. UPSs are almost back to normal. I would say when you're looking at 2 megawatt blocks, they're going to have a little bit larger of a lead time, but I think that's all going to start coming down fairly soon. Large gear, and maybe you want to jump in on some of this, 4,000 amp breakers and what have you, used to be ridiculous, and I think they're kind of falling back in line. Would you agree with that, Meet?
Yeah, I mean, I think in general, the supply chain issues we've been experiencing have gotten better, but now we have a different set of issues, right? Now we have these large players that are ordering stuff and cornering production lines, a year at a time in terms of the particular size and blocks of loads that they require. Substation transformers, from the large power requirements, those are right around about 2 to 3 years lead time right now. And if you're looking at, any kind of medium voltage switch gear, you might still be up against some, significant lead times. But it's better than it was, but I don't think it's quite where everybody needs it to be. But, on the bright side, you can't get power to the side anyway. So
One of the comments at YOTTA that I was listening in on was that lead times right now for turbines is now rivaling what we were looking at for transformers,
yeah,
which was interesting.
their
There's
lead,
that much. There's that much in scale of adoption at the moment.
yeah, that was, that's the thing is that, everybody started looking at on-site generation using turbines because they were, about, let's say, an average, a year out. But because of the demand of those and everything else involved, now they're basically running close to 2 to 3 years as well.
Yeah. Hey, we have reached our full time. Brad, were there any more questions? If there are questions, I can respond to those online
That was the
on
last
our
of it.
LinkedIn page. That was it? Okay.
Yep.
Well, listen, I want to thank everybody for participating today. I specifically want to thank Ryan for joining from our Phoenix team, from our Arizona team, I should say. I know you've got an event down in Tucson tonight. I'm jealous, being a former University of Arizona guy myself, and look forward to having you again participate again in the future. Thank you again to our board. Without you all volunteering your time, we wouldn't be anywhere. I truly appreciate it. And again, thank you everybody for joining. I know most people kind of watch this on YouTube at their leisure. And so we thank you again for your participation and support of our chapter. And with that, I'll say until the next time on our holiday social, stay tuned for our updates on social media on LinkedIn, and look forward to seeing you next time.
Thank
Thanks,
you all.
everybody.
But